We need to obtain the derivative of y with respect to x whenever x and y are given in its parametric form. That means x and y are both dependent on the parameter theta. So let's begin our problem by considering whatever is being provided to us. We will start with x equals to a e raised to the power of theta multiplied to sine theta minus cosine theta. So first step, what we'll do, we'll take the derivative on both sides with respect to theta. So we have dx over d theta, this will be equals to, a is a constant, so this will get multiplied to derivative with respect to theta of e raised to the power of theta whole multiplied to sine theta minus cosine theta. Right. Now we'll find the derivative. Here, since we have the product of two functions, e raised to the power of theta, sine theta minus cosine theta, we're going to use the product rule. So here we'll have e raised to the power of theta. This will get multiplied to derivative with respect to theta of sine theta minus cosine theta. This will get added to sine theta minus cosine theta multiplied to derivative with respect to theta of e raised to the power of theta. Fine. So this will be equals to a multiplied to e raised to the power of theta. Then I will take the derivative of sine theta minus cosine theta. Derivative of sine function gives us the cosine function. So here we have cosine of theta minus we have derivative of cosine theta, which will be negative sine theta. Since we already have a negative sign, this will become positive sine theta. This will now get added to sine theta minus cosine theta, and derivative of e raised to the power of theta will be e raised to the power of theta. Now what we'll do, we'll combine the terms within the parentheses. So we can also pull out e raised to the power of theta because that's the common factor. This will now get multiplied to cosine theta plus sine theta plus from this particular term, second term, we have sine theta minus cosine theta. So here we can see that cosine theta and negative cosine theta gets cancelled out, and this gives us the value for derivative of x with respect to theta, which will be equals to 2a times e raised to the power of theta times sine theta. We're going to label this as equation number 1. Now what we'll do, we'll start with the second equation, meaning we'll start with y, which is given by a e raised to the power of theta times sine theta plus cosine theta. So we will take derivative of y with respect to theta. So this will be equals to a multiplied to, so we'll take e raised to the power of theta as the first function. This will get multiplied to derivative with respect to theta of sine theta plus cosine theta added to sine theta plus cosine theta. This will get multiplied to derivative with respect to theta of e raised to the power of theta. Right. Now we have a multiplied to e raised to the power of theta multiplied to, we'll take the derivative of sine plus cosine theta. Derivative of the sine function gives us the cosine function, and derivative of the cosine function gives us negative sine theta. So this will get added to sine theta plus cosine theta multiplied to derivative of e raised to the power of theta with respect to theta will be simply e raised to the power of theta. Right. Now what we'll do, we'll take e raised to the power of theta as the common factor from both the two terms. So this will be the first term and this is the second term. So this is going to leave us with, so here we have cosine theta minus sine theta. This will get added to sine theta plus cosine theta. Right. So now we see the negative sine theta and positive sine theta cancels out, and this leaves us with a e raised to the power of theta. So cosine theta plus cosine theta will be 2 times cosine theta. So we have obtained the value of derivative of y with respect to theta as well. We're going to label this as equation number 2. So our goal is to obtain the value of derivative of y with respect to x. So what we'll do, in order to find out derivative of y with respect to x, all we have to do is take equation number 2 and divide it with equation number 1, meaning we'll take dy over d theta and divide it with the result obtained for dx over d theta. So this will be 2a e raised to the power of theta cosine theta divided by 2a e raised to the power of theta times sine theta. So 2a e raised to the power of theta, this gets cancelled out. We are left with cosine over sine, and this ratio is simply the cotangent of theta. Therefore, we have finally obtained the value derivative of y with respect to x. This is equals to cotangent of theta.